Hi all, welcome to one more classes in econometrics. In previous video, we have seen that OLS estimators or regression coefficients that are derived through a process called OLS will be minimize the errors. Okay, and that's why we are calling it as a ordinary least square method. Okay, but in order to minimize the squares of the errors and thereby giving a best linear unbiased value for the OLS estimators, we need to satisfy certain assumptions. Okay, yes, so we will discuss what are these assumptions are. Okay, and in the examination point of view, it is very important. These assumptions are very important. Okay, so there are mainly three categories of the assumptions. First category is assumptions about the model. Second is assumptions about the error terms. Okay, and third one is assumptions about the sample or assumption about the sample data. Okay, so these three are the major categories of these assumptions. Okay, so we will discuss this assumption by one. First assumption. Okay, so first assumption is the model is linear in parameter and the model is correctly specified. This is the first assumption. The model is linear in parameter. What does it mean? The linearity. Okay, it means that the beta 0 and beta 1, the parameters should be appear with power 1 and it should not be divided or multiplied with any other parameters. Okay, so it means that the power of the beta 0 and beta 1 should be 1. It should not be square, it should not be cube. Okay, and it should not be divided with any other parameter, beta 0 divided by beta 0 beta 1, or beta 1 divided beta 1 into beta 0. It should not be divided or multiplied with any other parameters. Okay, and this linearity implies that a one unit change in the independent variable will have the same effect on our the dependent variable irrespective of the initial value. Okay, so this is the peculiarity of the linearity. The when one unit change in x will lead to the same unit change in the dependent variable irrespective of the initial value. Okay, so OLS only deals with linear estimation and it will not deals with non-linear estimation. That you have to. Okay, so if you draw a graph for the data and if it just look like a reverse U-shaped or U-shaped, okay, then you cannot use OLS. You cannot use regressions. That's the first assumption. Second assumption is non-stochasticity of xi. What does it mean? It means that the value of the independent variable should be vary within the sample but should be fixed in the repeated sample. Okay, so from a population we are taking a samples. Okay, within the sample your x value should not be constant for all, it should be vary. Okay, but when you compare one sample value with another sample value, there the x values of the both samples should be the same. Okay, so why we are assuming these things? Okay, because when all the x values in a samples are same, okay, the x bar will also be same. Okay, so when we come to the equation of beta 1, it is sigma x minus x bar into y minus y bar, or sigma y into x. Okay, so this y and x will be equal to 0, so it will be the beta 1 will be 0 divided by 0, which is equal to 0. Okay, so we cannot estimate the beta 1 if all the values of x are equal to 1, or if all the values are 1 and same. Okay, that's why we are assuming that non-stochasticity of ui, which means that the value of xi should be vary within the sample. Okay, and third assumption is mean value of ui is equal to 0. That means average value of your u term is 0. Okay, it means that sometime, okay, the values will be the errors will be positive and sometimes the errors will be negative. Okay, but should not be but the average of this error should be 0, and there should not be any systematic tendency of this u to vary in either of the direction, positive or negative. Okay, there will be positive errors and there will be negative errors, but when you take the average, it will be should be equal to 0. Okay, yes. Then the fourth assumption is, so that you can mathematically express it as a expectation of ui given xi is equal to 0. Okay, expectation of, that means average value of ui for a given particular level of income or x should be equal to 0. Okay, so you look at the graph, you can see that the average value, the conditional line or the regression line will passes through the conditional mean values. Okay, so when you compare this conditional value with other values, you can see that there are positive errors and negative errors, but the conditional value will be the exact average of these values. Okay, then this, when you take the average of this all these errors, you can see that these errors, the average errors will be equal to 0. So that's the third assumption. The fourth assumption is very important assumption, which is called the homoscedasticity assumption. Okay, so homo means equal, scedasticity means variance. Okay, so equal variance of what? Equal variance of the error term. Okay, so equal variance of the error term means what? The variance of the error terms should be a constant number for all xi. Okay, so when we estimate the variance, when we estimate the mean value should be equal to 0. That's the third assumption. But when we estimate the variance, okay, so there are different income groups, as I told you in the previous examples, 80 income groups, 100 income groups, 120 income groups. Okay, but in all these income groups there will be the variations, but the variation should be the same for all income group. Okay, so the variance of ui given xi is equal to same value, that is equal to small sigma I square. Okay, so small sigma I square is a notation to denote it as a constant value. Okay, so variance of ui given xi should be equal to a constant positive value. Okay, so how we can depict this in using the graph? You look at the first graph, x1, x2, x3. These are all different income groups or different values of xi. But if you draw a graph, if you draw a distribution, you can see that the width of the distribution are same. Okay, but when you look at the second graph, you can see that the distributions are vary in terms of the variance. Okay, in the first case, x1 case, the distribution is not that much wide. Okay, it is more peaked. Okay, but in second case it is mesocortic, but in third case it is leptocortic, or sorry, platycortic. Okay, it means that in different level of income groups, the variation among the income groups or variation in the consumption are highly varying. Okay, that should not be happen in OLS. Okay, if it is happen, then your OLS estimation will be wrong. Okay, so in reality, this will not be a case. There will be, if there are 5 different industries or 5 different firms, in all firms there will be a considerable variations. But in reality, this assumption may not be hold, and if this assumption is not holding, then there are certain problems. Okay, yes. And the fifth one is no autocorrelations. Okay, so you might have learned correlations. Okay, the correlation means what? The relationship between two different set of variable. What is meant by autocorrelations? Correlation within a single variables. Okay, so how we can find out the correlation within a single variable? Correlation within single variable means correlation within the different time lag. Okay, correlation between today's values and yesterday's values, correlation between the last year value and this year values, or correlation between this year value and last 5 years value. This is what we call the autocorrelations. Okay, but in OLS assumptions, the autocorrelation means what? Autocorrelation between subsequent error terms. Okay, for first y and x there will be an error, that's called u1. In the second observation there is another u2. Okay, third u3, fourth u4. Okay, but this u1 and u2, u2 and u3, u3 and u4, and u1 and u4, u1 and u3, all these pairs, the covariance or correlation should be equal to 0. There should not be any correlation between these u1, u2, u3, u4 and all. Okay, so we can say that the subsequent error term should be uncorrelated. How we can express this in mathematically? Because using covariance we can express, because covariance is measuring the relationships. Okay, so covariance between ui and uj. Ui is a one u value, uj is a next u value. Okay, given on xi and xj. So it means that ui value corresponding to xi value. Okay, then uj value corresponding to xj values should be equal to 0. This is what we call covariance. No autocorrelation. Sixth assumptions. Okay, no correlation between xi and ui. That means your independent variable x and your random error term ui should not have any correlations. Okay, so no covariance between your disturbance term ui or error term ui and your independent variable xi. Okay, yes, that's the 6 assumptions. And 7th assumption. Okay, so the first assumption, linearity and no specification errors, was the assumptions related to the model PRF. Okay, and the third assumption, so second assumption, that means non-stochasticity of xi, okay, is related to the sample values. Okay, then the third assumption, mean value of ui, then homoscedasticity, no autocorrelation, then covariance of ui and x is 0. These are all about the assumptions related to error term. Okay, now the 7th assumption, the number of observation is n must be greater than the number of parameters to be estimated. Okay, so in a case the parameters means what? Beta 0, beta 1, something, okay, like that. Okay, so suppose there are 5 betas, beta 0, beta 1, beta 2, beta 3, beta 4. Okay, for estimating these things you need at least 6 observations. Okay, so n must be greater than the number of parameters to be estimated. Okay, that's the 7th assumptions. And the last assumption is the no perfect multicollinearity. It means that when you have more than one independent variable in your regression, that will happen only in multiple regression model. Okay, so in the multiple regression model there will be more than one independent variable, but this independent variable should not be perfectly correlated. That means the correlation should not be equal to 1. between these two independent variables. Okay, so the last assumption will be hold only in the multiple regression models. Okay, so these are all the 8 assumptions of the ordinary least square assumptions. Okay, so the first one is linearity and non-specification error. Second one, non-stochasticity. Third one, homoscedasticity. Fourth one, no autocorrelation. Next one, the covariance between error term and explanatory variable or independent variable is equal to 0. Okay, then n must be greater than the number of parameters to be estimated, and last one is the no perfect multicollinearity. Okay, so these are all the assumptions. If a question is being asked what are the assumptions of OLS, then you write down first one, linearity in parameters and no specification mistakes or no specification errors, first one. Okay, the non-stochasticity of xi, second one. Third, mean value of ui is equal to 0. Fourth, no homoscedasticity, that means variance of ui is a constant number. Okay, then no autocorrelation. Okay, then no correlation between the error term and your independent variable. Then seventh one, n must be greater than the parameters, okay, to be estimated, and last one, no perfect multicollinearity. That's fine. Okay, yes, so depending upon the mark of the question, you can add the equation and certain explanations. Okay, yes, and one more thing I would like to tell you that, okay, so if all these assumptions are satisfied, then only you will get a value for your beta 0 and beta 1 that minimize your error terms or that minimize the errors in your models. Okay, we want to get a model with a less errors, that will be only get if all these assumptions are satisfied. Okay, and if all these assumptions are satisfied, okay, and the parameters that we got or the value that we got for beta 0 and beta 1 will have certain desirable properties. Okay, so if all these assumptions are satisfied, then our estimators will have certain desirable properties. Okay, and these desirable properties are summarized by Gauss and Markov in their theorem called blue. Okay, so if all these assumptions are satisfied, then the estimators will be blue. Blue means what? The estimators will be best, linear and unbiased. Okay, so if all the assumptions of OLS are satisfied, then the estimators thus obtained will be best, linear, unbiased. This is what we called Gauss-Markov theorem. Is it okay? So if a question is asked what is the Gauss-Markov theorem or what is blue, you have to write that Gauss under the assumptions of OLS, or if all the assumptions of OLS are satisfied, then the estimators obtained will be best, linear and unbiased. Okay, so what is best? Sorry, what is linearity? Linearity means the OLS coefficient beta 1, that means the slope coefficient can be expressed in terms of the samples values of y. Okay, you just remember that, you just mug up that linearity means the OLS coefficient beta 1 can be written as a linear function of the sample values of y. Okay, I am not going for the derivation and all, you just mug up this. Okay, then what is the unbiasedness? The OLS coefficient beta 0 is unbiased. OLS coefficient beta 1 is also unbiased. What is unbiased means? Your sample estimator beta cap 1 and the population parameter beta 1 should be equal to same value, or the difference between the beta cap and beta should be equal to 0 or will be equal to 0. That is the unbiasedness. Okay, then what is the variance? The third one is the minimum variance. Okay, it means that the variance of the beta 0 and the variance of beta 1 should be minimum or will be minimum. Okay, then the fourth one is the consistency. That means whenever you increase the sample size, your parameters or the statistics will be approached to the parameter. That means your sample estimator will be approached to the or will be equal to the your population parameter or your PRF parameters. Okay, when you increase the sample size, your SRS will be approached to the PRF. Okay, so that is all about these properties of the OLS. So under the assumptions of A1 to A8, that means if all the assumptions of OLS are satisfied, then the estimated then obtained will be best linear unbiased. Okay, so in this, what is meant by best means unbiasedness plus minimum variance. Okay, so if both are satisfied, then we call it as a best. So best linear unbiased. Okay, so this is what we call the Gauss-Markov theorem or properties of OLS or blue. Okay, once again I'm repeating that if assumptions of OLS are satisfied. Okay, so if all the 8 assumptions discussed is satisfied, then the OLS estimators obtained will be best. Okay, will be linear and will have minimum variance, and apart from this, in large sample it will be asymptotically efficient, or you can say that it is consistent. Okay, so this is what we call the best or blue or best linear unbiased, or what we call the Gauss-Markov theorem. Okay, so this is what about the assumptions and properties of the OLS. Is it okay? Yes. So thank you.